All right, I'm going to put it in a package. Let's call them threads. Okay, so let's write let's write the first class. That's just I'll just call it a not a fist thread, a first thread. Okay, so again, all the concepts that we've been talking about are applicable here. So if I say implements Runnable, that's an interface, and then NetBeans lets me implement all the abstract methods. There's one abstract method called run, and run is where I'm going to have the thread do whatever it does. But it's still just a regular old class, so let's give each one its name. Just to distinguish them, and then write a constructor Okay, so each one's just going to have a little name. And okay, suggest making it final. That's okay, because we're never going to change it. I'm not even going to write a getter or a setter or anything like that. But run is going to where we're going to do business. And so again, let's just sort of say let's say when we start, we're just going to say, okay, I'm starting, and we'll give it our name. And then, I'm going to, let's do this in an infinite loop, just because I don't. All right, here's what we're going to do. We're going to sleep. Okay, so now thread has a method called sleep, and then there's like an interrupted exception that it throws. Again, you've been seeing exceptions, you've been experiencing exceptions. We'll kind of touch on a little bit about what that's all about. But basically, certain tasks may throw an exception, and what you want to do is you want to catch them, and here we're just going to catch them and sort of log that. So, all right, so thread sleep takes an argument, and the argument requires a long. That's why I put the L there. You don't have to, but I do, and you know why I do, right? Just to make it clear that I know that this is a long, and I'm putting a long in, not that I'm putting an int in. An int can always get promoted to a long. So if something requires a long, I can always put an int in. But I make it a habit that whenever something is going to require a long, I put the L in to show that I know this is a long. And what does that value mean? That is, the units are milliseconds. So this says that this thread is going to go to sleep, meaning it's just going to wait for 500 milliseconds, approximately, again, and then it's going to wake up and then start processing whatever comes there. So 500 milliseconds is basically half a second. You can make that whatever you want. And I'm just going to say, here I am. Oops. All right, so now what type of, okay, I've invoked thread sleep, and now what type of method is sleep? There's only one thing it can be. Well, there are only two possibilities. It can be an instance method, or it can be a class method.
Class method.
It has to be a class method because I'm invoking it as on a class, whereas the run method is an instance method, because I'm going to, it's an instance method, but I'm not going to invoke it on the object. Okay, so this is, in general, when you're writing a thread that's going to do something, then you put it in the run method, because that's what's going to get called by the thread scheduler, basically. Okay, so, and this is just kind of doing something. If you're doing something that's a task that's going to take a little while, like maybe downloading a large file from the internet or doing a lengthy calculation, again, what this can do is this can keep everything else live for you, and that's what you want. All right, so let's test this out here. So, all right, so here's how and again, this is kind of the bare metal way of doing things. All right, so I'm going to create a bunch of these, and as I create them, I'm going to start them off. Now, the thing about, okay, so let's, let's try 5 at first. Why do you keep pinging me? I thought I turned you off. Okay. All right. So we're going to create 5 of these. So so here's how we do it. Let's I'm going to do it in steps. And let's let's sort of give each one their own number. Okay, and I called it first thread. Maybe that's a little bit of a misnomer, because it's actually not a thread. That's not a thread. It's a runnable. So maybe this would be better called a first runnable. All right, let's call it that. Okay, so what I do is I create a thread. Okay, so I have 2 objects running around here. For one is, let me rename this. Okay, so yeah, what I'm now calling first runnable, because it's not a thread, it's just a runnable. But I'm instantiating a thread, and I'm passing the runnable to the thread. And what that does is that tells the thread that when you do your thing, use the run method from this guy to do that. Okay, so now nothing is going to happen until I start the thread. So I've instantiated the thread, and now I say run thread start. Now the thing, what we're mostly used to, when you invoke a method, up until now, the program will wait until you return from that method, and that's always true. But typically, inside that method, it's doing a bunch of stuff, and you're sort of sitting here waiting. That's not what happens here. What happens here is it kind of starts things off on the thread scheduler, but then it returns immediately, even before anything happens. So that can be a little bit unusual. So okay, so normally, if I were to write something in a for loop like this, and then say, okay, we're all finished, then by the time I get here, everything that's been processed in this for loop will be finished, right? I mean that's what you would expect. That's the absolute natural thing to expect. So what we would expect is we would expect to see a bunch of things. In fact, this is an infinite loop here, so we would expect to not see this for a while, if ever, right? I mean, you know, think about how you would expect this code to produce. You would expect it to see a bunch of these statements, these print statements, or whatever that happens. And when that's all finished, this would happen. That's not what happens. What happens is this is the very first thing we're going to see. So in other words, this starts everything off, but just keeps on going. So we're going to see this statement first, and then we're going to start to see a bunch of these other statements. The other thing is that notice I'm doing things, I did 0, 1, 2, 3, 4, again, the silly zeros-based thing. And so I would expect them to be appearing in order, like the 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, like that, right? That's what you would expect. That is, in all likelihood, not what we're going to see. Because the thread scheduler is going to be kind of basically pick one seemingly at random. And so we're going to see 0 through 5, through 0 through 4 all mixed up in various orders. Even though each one is doing exactly the same thing. Each one is waiting for exactly half a second and then popping up. And then waiting for a half a second and then popping up. Even though they're doing exactly the same thing. And so we would expect them to be in order. They are not going to be in order, or they shouldn't be in order. All right, let's sort of see what. Okay, so. All right, so here notice what happened. Okay, so actually first, that 0 thread got going first. And then the 4th one got in. And then we said that we're all finished. And then 3, 2, 1. And then the order is completely, at least seemingly completely random. There's no rhyme or reason to it whatsoever. Which is what I was saying. That's why this is sort of weird. Okay, so again, what we're after is trying to keep our programs live. That's the one reason for this. The second reason is that these things are actually operating simultaneously, and if there are multiple processors, what the Java virtual machine does is that it exploits that. So in other words, if I have multiple processors, then each of these threads may be assigned to a separate processor, which means they're essentially operating independently. So if each of these tasks that I have here, I mean, here I was just sort of doing something silly, but let's say that I have a bunch of tasks that I want to perform, and I can kind of perform them more or less independently, one from the other. I can, if I perform them if I write it so that sequentially, let's say each task takes like 2 seconds to run, but I have 100 of them. So that would take a total of 200 seconds. Well, let me back off from that. Supposing I have 8 processors, and each task takes 10 seconds. If I did it sequentially, that would take 80 seconds. If I do it like this and put each one in its own thread, it will take a little more than 8 seconds total to get them all done. I say a little more because there's overhead going on here. But because they are executing simultaneously, they're basically multitasking, then there's a substantial gain in execution. So, okay, so Now the thing is that the book gets into kind of how these when you create it, it's runnable, and then what's happening here is that it's when we first start, it's runnable. When run starts, it comes in here. When it waits, it's sort of waiting. And then when it's executing here, it's executing, and then it waits again, then executes, and then waits, and then it bounces. And then finally, in this particular case, we never actually get there. But when it finally returns from the run method, then it's done. And as a thread, you're basically you're kind of stuck. You can't restart it. And even though Java was one of the first languages to have threads built in to the language itself, which was a significant advance, nevertheless, they kind of screwed it up at first because it's actually a very difficult thing to do. So it took them a few iterations, and what they finally landed on is some classes that should be used instead of doing what we're doing here. That is, instead of directly dealing with the what we should be doing, in the graphical interface and what I'll have you do there, we will be doing something like this. In other words, we'll be kind of creating a thread and starting the thread. But that's about as far as we're going to go on that. If you're trying to do multiple threads, especially for the task that I was describing before, where I have multiple multiple computations, multiple expensive computations that are more or less independent, but I want to do them all. If I do them in parallel using threads, then there are these things called executors that will handle all that for me. And we'll see what that's about tomorrow, because I don't have enough time to get into it right now. But basically what the executors can do is we can say, okay, I can actually create an executor that has one thread at a time. I can create one that has as many as it needs at a time. I can create one that says, okay, I'll give you 10 threads. And then when the threads return, the thing is that when a method gets executed, one of several things happens. And the main two things are it successfully executes, and the other is that it throws an exception. Remember, if you've been doing any programming, you have encountered exceptions. That's that red stuff and little links that say, ah. Okay, so what do you do? How do you handle it if this run method throws an exception? Well, that's where these executors come in. There's a way of catching those exceptions and dealing with it and knowing whether or not this particular thread executed successfully or whether it threw an exception, and then you need to figure out what to do. Because if you have multiple threads and you don't do anything to deal with that exception, it will shut the entire program down. So let's say I have 10 of these expensive computations that I'm doing. They're chugging along and chugging along. If one of the threads throws an exception and I don't handle it properly, the entire virtual machine shuts down and I lose everything. And losing everything is not a good thing.